In this video, we're going to take a look at a way to write better tests for your Angular components. The title of this video may seem odd, but if you care about the quality of your tests, then this video will be worth your while. We're going to use a simple component to concentrate on the issue of testing, but the concepts apply just as well for complex components. This is the component we'll be working with. We can enter numbers in the boxes, then click the Add button, and the sum is displayed on the label. Let's go to VSCode and test this component. When it comes to testing components, most people start with the wrong question. They would look at the code and ask, how can I test this? They would look at the add method, see that it calls the sum function, and then proceed to test the code. Here are some of the wrong ways they could test this component. They would check that add call sum. They would spy on sum. Invoke the add method. And then expect sum to have been called. This kind of test is typically reserved for external calls, to make sure they're being invoked. In this case, it's not doing any favors. Another thing they would do is test that add uses the result of sum. They would spy on sum and make it return some value. Then call the add method. And finally expect the result property to have the returned value. This test is better, but it is too coupled with the implementation of the component. Any kind of refactoring will break the test. Another test they could do is to forget the add method and concentrate on the sum function. They would call the sum function with some values. And then check the result matches the expected value. This one is less coupled to the implementation, since it only knows about one method of the component, but it doesn't really test what the user can do with the component. All these tests are easy to create, some can even be automated, but they don't really test the most important thing, the user experience. The problem is that these tests start with the code, and then set out to exercise the implementation. But what if we don't set out to test the code? Instead of asking what the code does, a much better question is, what can the user do with this component? So let's forget about the code and go back to the beginning. What is the experience of the user? They start with two text boxes plus a label with zeros and a button. They can enter numeric values on the text boxes, and when they click the button, the label shows the sum of the two numbers. We're going to test just that. There are some tests here, but they're based on the code, so let's get rid of them. We'll create a describe block in which we render the component. Then we verify the initial values of the text boxes and the label. After the component renders correctly, we want to enter some numbers in the text boxes in its own describe block to keep things organized. Then maybe validate something and click on the button. The final step is to verify the label shows the correct value. Now that we have a plan of what we want, the tests almost write themselves. Let's start by updating the UI. Since we're using Forms module, we need to wait for the fixture to be stable, and then run change detection. To check the value of the text boxes and label, we need to query for all input elements, and also for the label. Then check if their values are zeros. To type into the text boxes, we need to query for the inputs. Then set the value of the input, but it isn't enough, here we're just setting the internal value of the element. To let the rest of the application know about this change, we need to dispatch the input event for it. And we do the same for the other input box. Clicking the button is straightforward, but we need to call detect changes for Angular to process the changes. And finally, we can check that the label has the correct text contents. Notice how we're able to test the actual functionality of the component without looking at the implementation. The tests don't have any references to the code. Now, you may be wondering why this is better than the usual testing techniques you see everywhere, and why we're talking about testing Angular components this way. Two reasons. First, it decouples your tests from your implementation. We just tested the component, and we don't even know about the implementation. We only have to know what the user experience is. Second, it makes testing much easier. This simple example doesn't show it, but for complex components which pull data asynchronously, react to events, and the logic isn't straightforward, testing the UX is much easier and simpler than following the code. If this feels eerily similar to an end-to-end test, it's because it is. The best test is one that mimics the actual experience of the user. Unfortunately, those tests are slow and expensive. With Angular we have the nice compromise between fidelity and speed. We can test the user experience with relatively high fidelity at a unit test speed, provided we accept that we're testing the components in isolation. This means end-to-end tests are still a necessary part of your testing strategy to verify the application works as a whole. Now let's see how well these tests do in the face of change. First, let's run the tests and see that they pass. We're going to delete the logic from the class and move it to the template. Now that the template has the logic, we can save and our tests still pass. Either way, our tests still work because they're testing the most important thing, the user experience. Had we tested the code, all of our tests would be failing, even though the functionality of the component stays the same. That's all for now. If you found this video helpful, check out the SimonTest extension for VSCode. It takes care of the most tedious part of testing components and services, stubbing dependencies. SimonTest analyzes your code and creates the necessary stubs, configures the TestBed, and it even generates basic tests. Search for SimonTest on VSCode extensions. Ask your company about getting a license for you and your team.